we're going to look at, if you don't like division, how can you instead use multiplication to help you out? Because there's a lot of equations where you could definitely use multiplication instead of having to pull out a division algorithm or deal with division at all. You could almost just use your best, the multiplication, and ignore almost that you might otherwise have to use a division algorithm or long division or short division or anything of that nature. So because division and multiplication are inverse operations, you can think, well, instead of sharing 128 between 4 people, 4 groups of what gets me close to 128? And we want to get as close as possible. And it's more of a trial and error process here. So 4 groups of 3 makes 12. So 4 groups of 30 or 4 groups of 3 tens makes 120. So instantly I'm really, really close. And I've therefore got 30 locked in. I'm going to lock it in because I'm very close. And then I need 4 groups of 2. Makes 8. If we add these two together, that's our total. So basically 4 times 32 makes 128. Therefore 128 shared between 4, everyone will have to pay $32, or that's your answer. No need to rename, no need to go into this, no need to pull out long division, just multiply to get to it. Let's go another one. So 842 shared between 8. So instantly thinking, oh, it's going to be something 100, because 8 groups of 100 makes 800. So let's pull out that first and let's get that written down. 8 groups of 100 makes 800. Locked in. Definitely going to do our 8 groups of 100. Now we want to make this 42 to share the 42 out. So 42 shared between 8, or 8 groups of what gets me close to 40? 8 groups of 5. Gets me really close to 42. It locks in 40. And then I'm just too short because I got my 800, tick, got my 40, tick, just need my 2. I can't share 2 between 8 unless I'm going to go into decimals and make them cents rather than dollars. So let's just put the 2 as the remainder. And so the answer is 105, remainder 2. You can go back and check. 8 times 100, 800. 8 times 5, 40, plus the 2, 842. All good. These are probably the one I most recommend to use this strategy for, because 2-digit ones, using it with long division or short division, it just becomes a nightmare. So instead, use multiplying. So let's think about 396. We'll do, 2 times 15 equals 30. So if I put 15 on this side so I can keep track like I did up here, 15 times 20 will therefore be 300. So I've already knocked out the 300, and I don't have to do it bit by bit. I could do 15 times 23 and see where that gets me. But it's good if you could knock out the hundreds, then the others separately. I've pretty much got another 100 in here. So I'm going to think, okay, 1 15 would be 15, 2 15s would be 30, 4 15s would be 60, 6 15s would be 90. So I'm going to go 6 15s is 90. So 15 times 6 knocks out 90. And then 6 shared between 15, unless I go into decimals, can't be done. So we'll leave that as a remainder. So the answer is 26, remainder 6. And then you can multiply it. I'd probably use lattice method to check this. Pull out the lattice. Finally, we're going to try this one. So again, think about what it could be close to. This one, there's no obvious link to the tens. But it's pretty close to 5 times 9, 45. So 45 tens. So 9 times 5 is 45. So 9 times 10, 50, or 9 times 5 tens, will be 450. Oh, my apologies. So close. So close. So really, what we need to do from here is we're at 450 with 9 times 50, and we'll lock that in. And we just really need to think, well, if we add 2 9s, that's going to be 18 more, 468. That's not something we have available to share. So it's really just going to be 1 more 9 and then remainders. So it's going to be 51, which would make it 459. And then the difference between 459 and 463 is 4.